Hi, today we're solving problem number 40. We're given an irrational decimal fraction created by concatenating the positive integers. So here we have a decimal. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 10, 11, 12, 13, and it goes on like that. It can be seen that the 12th digit here highlighted in red of the fractional part is 1. If d sub n represents the nth digit of the fractional part, find the value of the following expression. So we have d1 times d10 times d100 all the way up to d1,000,000. So the way we're going to solve this problem is by canceling out the numbers in a group where all of the numbers there have the same number of digits. So this would be one group, and then 10 all the way to 99 would be a second group. And since these groups, each of the numbers has the same amount of digits, we can easily calculate the total number of digits in each group and cancel them out given the position of a digit we want to find. So we're going to implement this tail recursively, and I'm going to go over to IntelliJ. I'm going to create a def digit at index. This is going to take an index of type int, and to make the math simple, we're actually going to have I be 0 based. So instead of d sub 1, we would do d sub 0 when we're actually going to calculate the final answer. And we're going to take a second parameter, which is digits. And what digits is going to say is what group are we currently in, and in that group how many digits there are. So this is going to be an int, and this is going to start out as 1. Now this method is going to return an int, and we have to provide that since this is a recursive method. The first thing we need to calculate is the number of digits in the group with digits. So what I'm going to do is create a val, and this is going to be digits in group, and what we're going to do is first we need to figure out how far this range is going to span. And so what we're first going to do is we're going to calculate the total number of numbers in this range and then just multiply by the number of digits to find the total number of digits in the group. So if you go here, we can actually see a pattern here. There are 9 one-digit numbers. There are 90 10-digit numbers. There are 900 3-digit numbers. Actually, did I say 10-digit numbers? I'm not sure, but 2-digit numbers, there are 90, and 3-digit numbers, there are 100. So what we can actually do is we can do math. We can raise 10 to the number of digits minus 1 and multiply that by 9 to get the total number of numbers. So for example, in 10, we would do 10 raised to the 2 minus 1, which is 10, multiply that by 9, and that gives us the total number of numbers, which is 90. So I'm going to do math.pow to do the power. 10 raised to the number of digits minus 1. I'm going to convert this to an int because we know this is going to be an integer. And I'm going to multiply this by 9. So this gives us the total number of numbers. To find the total number of digits, we just multiply this by digits. Now the first thing we want to check is if I is less than the number of digits in the group, because then in that case, we can just jump to the number containing I and get that digit. So we can do if I is less than the digits in the current group, then the first thing we need to calculate is the index of the number in this group, and second, the index of the digit within that number. So first, to calculate the number index, this is really simple. All we do is do I divided by digits. So this will give us which index in this group is I going to be in. And then the second one is digit index, and this is almost identical to the top line, so I'm just going to copy this. But we're going to do I mod digits, which says what's the remainder when we divide, and that gives us the digit within that number. Now we can go ahead and return our answer. First, we need to calculate which number is at this number index. To do that, I just do math.how 10 to the digits minus 1. This gives us the first number in that group. Then I add the number index to this. I'm going to take this and convert it to a string. And then I want to get the digit indexed digit from this. So I'm just going to apply with the digit index, which gives me a character, which is the digit, and we're just going to do as digit to get that digit as an integer. Now let's say I is not less than digits in group. Well, then we simply recurse. We're going to do digit at index. We're going to cancel out this group. So to do that, we just subtract the digits in the group. So we're going to the next group, so we just knock out the digits that we can skip. And we increment the number of digits, because now we're looking at the next group. So you can test this out. I can go to maybe like, we can go to 20 digits. So we can do 0 until 20. So this is going to give us the first 20 indexes. I'm going to take each of these and I'm going to calculate the digit at index with that index, and the initial digits is 1. I'm going to print on this. And actually we can make string so that we get a nice clean answer, which shows us how it would look like within the decimal. And you can paste this into Chrome, and we see that we've gotten our right formula for calculating the digits. Now we need to calculate this product. This one's very simple. All we do is we iterate over the number of digits in each of these. So 1, 10. So this is from, and we can actually just do 0, or let's do 1. 1 to 6. So this is the number of trailing zeros for each of these numbers. So here, when we have 1 million, we have 6 trailing zeros. We map each of these to math.how 10 raised to, so we take, to that number. So that will give us 1, 10, 100, and we can actually just print this. So we see here, we get 10, 100, so we actually, good thing that we printed that out. We forgot the case with 0. So we get 1, 10, 100, 1,000, 10,000, 100,000, and lastly, 1,000,000. So we should actually probably convert this to an int, before we get the digits to those indexes. Now, one thing we have to watch out for here is this is using 1-based indexing, we're using 0-based indexing, so we have to take the I, and instead of passing I directly to digit as index, we pass I minus 1. We can run this now. And now that we have that, we just calculate the product, because that's what we need to find in this problem. And now we have our answer. So that's it for problem number 40. I'll see you next time when we solve problem 41.